Hey guys, welcome to this video. This is a continuation of the initial lesson on the triangle congruence theorems. So in this video, we're going to go over a few examples of how you can identify which of the triangle congruence theorems are going to work here. So just as a reminder, I'll write them up top here for you. The 5 congruence postulates we're allowed to use are side, 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 angle, side, angle, side, angle, 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 side, and then last but not least, the one that's a little different than all the others, hypotenuse leg. So we're going to use these 5 throughout this video as we go through different examples. So first thing we're going to do is look at these first 3 examples and go ahead and take a moment to see if you can identify which of the 5 triangle congruence theorems we're going to be able to use to prove why these 2 triangles are congruent. So pause the video now and give it a shot. And hopefully at this point you are back. So let's go ahead and start going over some of these. So in the first question, what I see here, and we'll use my highlighter for this, is we see a pair of angles that are congruent to each other, that are the same. We have 2 angles here that are congruent, and they are also the same. And last but not least, we have a pair of sides that are the same. So in this situation, we're really using 2 angles and a side. So the question is it angle, side, angle, or is it angle, angle, side? And the idea behind this is it's all about where the S is located. If the side is sandwiched between the 2 angles, then we would use the terminology angle, side, angle. If the side is not sandwiched or between the 2 angles, we would say AAS. So in this first example, the answer is angle, side, angle, since this orange side is sandwiched between the blue and the green angles that I have marked here. For number 2, we have a pair of angles here with 1 dash that are congruent. We have a second pair that are here with the 3 dashes that are congruent. And last but not least, we have 2 dashes here. So this one, pretty straightforward, is going to have a side which is orange, a side which is yellow, another side which is green. So we have 3 pairs of sides that are going to be congruent to one another. This is called side, side, side. And for the last one in this first set of examples, we're going to look and see that we have a pair of sides marked right here. And then the next thing we have is a pair of angles denoted by this single arc here. And then last but not least, we're going to have this orange one right here. So the question now comes down to, is this considered ASA again? So we're back to the same conversation from the first one. Is it ASA or is it AAS? And so for this one, the side is not sandwiched between. It's only touching the orange side, which means it is not sandwiched between it. So we're going to go in this case and call it angle, angle, side. Now, in a lot of these examples, everything's going to already be marked for you, so it's a matter of just identifying which of the 5 you're going to use. But in some examples, as you're going to see in these next 2 below, they're not necessarily going to mark something because we should be able to recognize it already. So an example here is, and I'm going to highlight the top triangle here in pink. So let me trace that out. I'm going to trace the second triangle down below here in orange. And what I want you to look at here is, even though there's only a pair of sides marked with a single dash and a pair of sides marked with a double dash, you might say, well, that's just 2 sides and there's not enough information. But what we're noticing here is that this AC right here is shared with the pink triangle and the orange triangle. And so if I were to cut it out and separate them from each other, like I'm about to here to help you visualize this, I've separated them out. Let me go back and add the markings. So we had a dash there, 1 there, and 1 there. So even though these sides are not marked, what I want you to notice is because since they both emanated from the CA, technically they are actually going to be equal to each other. And so this idea that CA, the pink CA, let me erase that and we're going to do it in pink. The segment CA and then the segment CA from the orange triangle, even though they are the same, when I separate them, that actually makes them equal to each other. This is called the reflexive property. Now, the name of this is not as important as it is to me that we recognize that this third side does exist, and so these 2 triangles are congruent by side, side, side. That's reflexive property, and the other one is vertical angles. And we've seen these in other places, but when 2 lines are crossing each other, as they are in this case, the non-adjacent angles, in this case, this one here as well as this one here, are going to automatically be equal. So even though they are not currently marked on here, what we see is we have side, angle, and side, and so these 2 triangles are congruent by SAS. And so to wrap this video up, we're going to go ahead and try to use these 2 in some more examples that are not as straightforward as the ones that we talked about in the beginning. So let's start with these first three, and as a reminder, these are the 5 choices that we can choose from when making that decision. So please go ahead, pause this video again, try it out, and we'll have the answers in a moment. So if you are back, that means we should have this done now. So let's go ahead and see for number 4. Since the top triangle and the bottom triangle both share this pink side, we can technically say that those are congruent to each other. That means that for number 4, the answer would be side, side, side. For number 5, because these intersections of these 2 lines create vertical angles, we can mark those as congruent. And so we have a side, we have an angle, we have another angle, same thing down here. The side is not sandwiched between the 2 angles. And so for number 5, this would be considered angle, angle, side. And for number 6, this is the first example you're going to get to see the different one here. There is a reflexive property because the 2 triangles, the left side and the right side, do share this side right here. And because this is an angle, technically over here, that's going to be a right angle as well to make a linear pair or make a straight line. So when I look at this, you might say to yourself, well, isn't this side-side angle? And this is the one that doesn't work. Think back to the last video when the donkey came up, that the reason why we're saying that. Side angle, the angle is not sandwiched between the sides, but the fact of the matter is that that angle is a right angle. And what that means that we can utilize here is hypotenuse leg. And so in this example, because the hypotenuses are congruent, the legs are congruent, and because it's a right triangle, these are actually going to be congruent by HL. So I believe we have 3 more final examples. I'm going to go ahead and have you try them out. Pause one more time. And welcome back. So in number 7, we have a reflexive. In number 8, we have a reflexive. And for number 9, we have vertical angles. And so if you didn't find those initially now, let's go ahead and take a look at how this is going to work. So with the reflexive property in number 7, this is going to be side angle side because the angle is sandwiched between the 2 sides. That's why we're allowed to call it SAS. In this one here, we have another side, an angle. This side here, once again, number 8 is also side angle side. And why don't we go for the trifecta? Because for this last one, we have 2 sides. The angle is sandwiched between it. And so for the last one, it is also SAS. I hope these additional examples have helped you recognize and see where we can use the triangle congruence theorems, as well as how the reflexive property and vertical angles are impacted in these problems. Thanks for watching.